Greetings and welcome to week 6, unit 4, rubrics for projects. In the previous unit, we understood how to design rubrics for technical papers and project reports. Now, in this unit, we will try to understand how to design rubrics for projects. One thing about projects, the evaluation or summative assessment is not a unique procedure. It depends on the department culture, and the institute culture, depending on the nature of students, discipline, and so on. So we'll try to understand all the dimensions of a project. In Indian UG programs, we have three types of projects. One is major project, which is up to from anywhere from 10 to 14 credits during 6th, 7th, and 8th semesters. And you have project-based learning units in some courses. And you have many projects which generally have 2 credits in 2nd, 4th, and or 6th semester. The nature of a project is, first of all, it can address several POs or several program outcomes which are not normally addressed in 3 credit courses. So one can decide which are the POs that you want to address and plan your projects accordingly. Okay, a project can be designed to address a stated set of POs. Now, the key aspects of major projects is you start with some kind of a vague problem identification, and then this problem will be generally ill-defined. You do not know the boundaries, the scope of that, and so on. It is ill-defined, and after that you have to convert into a well-defined problem. That is the first stage of important aspect of a major project. These issues consist of, like, the key aspect can be named as problem definition and literature survey. So you are addressing PO1, which all of you are familiar with, and then PO2 generally is not addressed in any of the courses, and then PO4. So what is it? Any complex engineering problem, we are assuming that an undergraduate project addresses a complex engineering problem. What is a complex engineering problem? It has multiple criteria, it has multiple stakeholders, and there are no unique solutions. Whatever solution that you finally choose will have to be justified. And then what happens, whatever solution that you identify, it may have different impacts on different stakeholders. So all these dimensions will have to be understood when you convert your problem definition into when you convert your problem identification into a formulate engineering problem. Then the first thing that you have to do is literature survey. Then whatever product that you want to develop, whether it is software or hardware product, then some general idea would be there, and there can be somewhat similar solutions produced by others. So you have, as a group, you have to analyze the existing solutions, patents related to that, and some research papers to establish the research gap, because you are not exactly trying to reproduce somebody else's solution in this. You are trying to find your own solution to this. So to that extent, in finding your own solution, you find some gaps in the existing products, and then you want to add those features to your proposed product. Now, having done that, then you state the problem. That is, the objective is clearly defined with specific technical specifications. There are two types of specifications: functional specification and non-functional specification. Functional specifications are whether whatever kind of output that you expect, exactly you have to define. If it is a signal, then frequency ranges, amplitudes, noise figures, and so on and on. Or if it is a software product, what kind of outputs the software should project under what conditions will have to be defined. And sometimes there are non-functional requirements. These are, let us say, if it is a hardware product, the physical size, what we call the footprint, the cost of the product, and its possible maintenance features, and so on. Same thing about software product as well. So the functional and non-functional specifications have to be clearly defined, because the entire design will depend on this. And then the next stage in this is, whatever you have chosen, whatever the group has chosen, is the scope realistic or not? That is, you have to develop, there may be a requirement or a justification for the product, but given the timelines and the budget constraints, will you be able to realize the product, complete the product in given time? So all these features will have to be done in one of the phases, that is problem definition and literature survey. And in this, while doing this, you will be addressing PO1, PO2, and PO4. The next thing is design and methodology. In this, you will be mainly looking at PO3 and PO5, which are technical in nature. Now, you create some kind of a blueprint in terms of system architecture, or let's say you create a good block diagram, or EML diagrams, or circuit designs. A block diagram would mean you identify several functional blocks, and for each functional block you have some input and some output. So the output of one block should match or should be in alignment with the requirements of the next block. So if you are able to draw a good quality block diagram and identify the inputs and outputs properly and see that they are compatible, that will be the system architecture. And in this, you may want to justify your design, or you may want to simulate your design using some of the software, or analyze any of the present day available tools like MATLAB, ANSYS, Python frameworks, and so on. And you also have to make a choice of the hardware components available in the market, and whether they will be accessible, available in time for you to do the product. You cannot just merely depend on some catalogs from other countries and say that I have ordered and I have not received the component. So you have to make your choices from what is available locally. Now you also have to justify in what way your approach to the design is somewhat different from the existing one, or what kind of improvements you are proposing. And in creating this design also, many times you may have to follow some engineering standards like IEEE, IOS, BIS during the design phase. If it is civil engineering, you have to follow some codes. So you have to identify what are the standards and codes that you need to follow, and your design will have to be within that. Then implementation and prototyping. Then having design means you are creating a kind of a plan to build. Okay, that is, if it is a circuit diagram that you create, you may have simulated the circuit diagram, but actually you have to implement. If it is a circuit on a breadboard, making sure that you actually get from the commercially available components the required outputs from that. So in this phase, this is practically the execution phase where the design is converted into a product. And the project is also generally broken into manageable modules, in the sense that you should be able to verify each module separately, and then you have to integrate. You cannot just test the product completely in one shot. And in this, you have to convince yourself that you are following the whatever standards, coding standards or hardware fabrication standards. So, hardware standard fabrication standards would mean how do you design your PCB, whether you are producing the right quality output which is translatable into actual PCB by some company, and soldering quality and so on. And then now how do you plan to test, and if you find any mistakes or any errors or bugs in the software, how do you propose to demonstrate that, as well as how do you solve the problem so that the bugs are removed? That is the third important aspect of project. Now, next phase you go into is testing and validation. Unless you validate your product, it's of no use at all. Just because you have gone through some design and you created a test board version or a prototype version, that is absolutely no use unless you are able to demonstrate that it meets the specifications that you started with. Mind you, a true project is whatever specifications that you choose, you must establish by the end of the product that you are meeting the specifications. Otherwise, you cannot give an excuse that my components are not working, or the time was not available, corresponding instrument is not available, and so on. Okay, you must create test plans right from the beginning. That is, once you complete the block diagram, you start saying that who will test and what is the test procedure that you want to follow to prove that. The test plan itself will have to be created right at that stage. And then you should also look at what kind of data analysis that you would do. That is, having measured and got the values, what are the type of how do you interpret the results? You cannot say that this is what I got, but how do you convince that the readings or data that you measured is as per the specifications? Okay, so these are the testing and validation part. Then you have impact analysis. For example, NBA emphasizes puts a great emphasis on engineers understanding the consequences of their work. So here, that's why impact analysis consists of PO6 and PO7, which are related to the impact of engineering activity on society as well as the environment. So societal impact and environment and sustainability aspects will have to be explored during this. And then there is also ethical dimension, that is PO7, that you are not infringing on something else, somebody else's work. So that part will have to be also kind of ensured that you are not copying somebody else's activity. Then you have project management and finance. As you know, all engineering activities are predominantly project based. Project based means you have limited timelines and limited financial and human resources. So this will have to be done together as a group. And when you have a group of designers, then management becomes the key. The next key aspect of evaluation projects is teamwork and individual contribution. Because whenever there is a team activity, you will have to make sure that all team members are contributing. They are not stepping on each other's toes. Their roles will have to be defined and they are able to collaborate. And if there are any difference of opinion, they should have the ability to resolve the conflict. And this is one very important aspect professionally that is required, and the students can learn by everyone feeling that the project should be made successful instead of blaming one another. Then finally, communication and report writing. Having done the project, having interacted well with one another, and meeting all the other requirements, you have to prepare a project report. And you also have to make a presentation. And everybody should be able to make a part of the presentation and also answer questions that are raised. And to ensure that you are getting your thing right, there should also be partly what you consider continuous. To ensure continuous assessment, you have to orchestrate the project. You must put timelines. At this timeline, we are going to evaluate like for this part and so on. And sometimes you can do it only to review and encourage the students to be on their way, or sometimes you can also give some weightage to that, certain percentage weightage to intermediate measurements. And as far as the project report is concerned, you can follow two methods. One is you look at this aspect only about the project report and correspondingly using a rubric evaluate, or we have presented in the previous one how to evaluate a large project report. With all the key aspects of the project report, we have created some rubrics, and those rubrics you use and give some marks for that, and those marks can be brought here as a part of this. So both ways are possible, and that decision will have to be made by the department. Now here, out of the 8, we have chosen 6 of them for creating a rubric. To start with, it is not that the others are not important, but if you have to make a choice, let us say I want to use only 5, then you have to decide which are the 5 dimensions that you want to address. Then here we have chosen problem definition and literature survey, design and methodology, implementation and prototyping, testing and validation, teamwork and individual contribution, communication and report writing. In this, we have slightly used different weightages. First one 15%, 2 and 3 20% each. The remaining ones carry 15% each. So you have to compute the weighted average for each evaluation. And then we have chosen 4 scoring ranges: excellent, good, average and poor. Excellent is 10 to 9, good is 8 to 6, average is 5 to 3, poor is 2 to 0. So when you are meeting all the requirements of this excellent, how many marks do you want to give between 10 and 9? That becomes a subjective judgment of the evaluator. Okay. So let us now look at the rubrics. That is, you have to write scoring criteria now. These are dimensions, weightages, scoring ranges are fixed. But when do you consider something excellent? You have to see that. And we will mainly look at the scoring criteria for excellent, because this is what each group, each team will have to aim at. Because I want to do excellently, and then you work towards that. And if you feel short of that, you may get good or average or poor, depending on how you have performed. Okay, let me read only the criteria for the excellent. Problem clearly and precisely defined with the scope and constraints. Comprehensive up-to-date literature survey, including seminal and recent sources. Clear gap analysis and justification of project significance. Clear research questions and objectives. So if you are able to put all of them together properly, then you will get between 10 and 9. Then design and methodology, a robust, well-structured design with appropriate architecture, models and rationale. Methodology is rigorous, reproducible and well justified. Appropriate tools and metrics are chosen. Risk analysis, alternatives considered, and ethical and feasibility aspects are also addressed. So that is the second part where it carries 20% weightage. Now coming to the third one, implementation and prototyping. Have been able to build fully functional prototype implementation meeting stated requirements. That is a fairly tall order, but depending on to what extent you have met that, you may get good or average. Clean, modular, well-documented code, design artifacts, good use of tools and technologies. It also demonstrates optimization, scalability, or thoughtful engineering trade-offs. Because any engineering project will have some trade-offs, whether you are doing the right kind of trade-offs or not. What is it that you are losing and what is it that you are gaining? Okay, testing and validation. Thorough testing strategy and well-designed experiments. As I mentioned, that is your testing methodology. Our strategy should be planned right from the beginning, not as an afterthought. Okay? Because then you will be prepared accordingly. Clear validation against requirements under benchmarks with qualitative, quantitative results. Test data reproducible procedures, error analysis, and limitations discussed. If based on the test data, what kind of limitations that you are forced to accept, that will have to be properly regarded. Now, fifth one, teamwork and individual contribution. This is a slightly difficult, and generally it should be based on peer evaluations. That is, each person of the team will evaluate the others according to an accepted form, accepted structure. Clear, equitable distribution of tasks, that is the first thing. Each member's contributions is well documented. Effective collaboration, leadership and conflict resolution, meetings and logs maintained. It is good to maintain a log of the meetings, what exactly was discussed, what decisions have been taken. Each time you formally meet, you have a meeting among the team members. And peer evaluations, consistent and collaborative contributions will collaborate, how you have collaborated with one another, if it can be recorded. If it can be recorded, it will be great value to you, because then you will be able to take care of yourself in the next project. Communication and report writing. Report is well structured, clear, concise and grammatically correct and professionally formatted. Figures, tables, references and appendices are complete and properly cited. Oral presentations is clear and well timed, uses visuals effectively and answers questions confidently. So if you do all this, obviously your performance is excellent. And then you combine each in the last column you enter out of 10 what marks you are planning to give, let's say between 10 and 0. And having put that, using the weightage, you use the total, compute the total like this. So that will give you the total mark of one evaluator. If you have multiple evaluators, that also can be done using this kind of a what do you call, Excel sheet. And these Excel sheets can be combined without wasting a lot of time of the evaluators. The net result can be computed, and also wherever you consider, let us say you are giving between 8 and 6. And in this, what is the feedback you want to give? Depending on what you consider, you can highlight that particular thing. Okay. If you highlight, that becomes the feedback. And the feedback will be of great use to the students as well. You don't have to separately prepare a feedback document. So rubrics that way will greatly help in reducing the time spent uh, by the evaluators in their evaluation, as well as giving feedback, and the feedback is meaningful because all these criteria are already written a priori, and these are communicated at the beginning of the project itself to all the students. So everybody knows this is what is expected of them and this is what they got finally. Okay. And as I said, once again, I would like to repeat, the projects play a very important role in integrating all the uh, skills and knowledge and attitudes that you have acquired during the 4 years, and it will prepare you correspondingly for the for the placement interviews. And in the next unit, we will try to understand how to plan rubrics for problem based learning. And thank you very much.